So hello and welcome everybody to the NFDI ToolTalk, and it's actually our first ToolTalk of the year. So I'm looking forward today to kick off the year of ToolTalks and hopefully many more to come this year. Today the talk is hosted by BERD at NFDI, and I'm happy to welcome the two speakers of today. Professor Dr. Klaus Tochtermann, who is the director of ZBW, Leibniz Information Center for Economics, and he is a member of the board of directors of the EOSC Association and also a member of the Scientific Senate of the NFDI. And with him today is Ahmed Saleh. He's a research assistant at ZBW and the CTO of BERD at NFDI. And today they are going to present us how BERD at NFDI is utilizing Invenio to build a powerful cloud-based research data management platform. So without further ado, the stage is yours, and I'm looking forward to your talk.
Thank you very much, Elena. Welcome, everybody. I think we should start screen sharing, Ahmed. I will do the first couple of slides to set the scene. So the talk is titled Cloud-Based Research Data Management Using Invenio. And here is the agenda. I would like to give a brief overview of what we will be addressing, and then a brief overview of the BERD consortium and the activities. And Ahmed will then delve into the details of the technical components of our activity. Next one. So BERD at NFDI stands for NFDI for Business, Economic and Related Data. So together with Consort SWD, that's the second consortium addressing data from the field of economics, but we address a slightly different community in the field of economics. In German, we would say we are addressing the Betriebswirtschaft, so business management. And our community partners do come from the University of Mannheim, which is the leading organization, the University of Hamburg, the University of Cologne, the University of Munich, LMU Munich. And the infrastructure partners are GESIS and ZBW, plus the library of the University of Mannheim. So that is the community. And actually in business management, we do not have a long-standing history of research data management. Unlike, for example, in other fields, I've seen here that participants from Text Plus are here, or Consort SWD has a long-standing history with the RAD SWD. Here, no research data management system does exist, no community has been established. And the community has specific needs for managing their data. And this is displayed in the figure below. So in the traditional empirical model, as it is known, for example, from the socio-economic panel, you have structured and standard data coming from surveys, for example, from interviews, and you use then empirical methods to analyze the data you have gathered. The focus in BERD is different. Here, our community partners are focusing on unstructured and non-standard data coming from digital sources. Unstructured data could be data which resides in business reports. It could be data which comes from web pages. It could be data coming from social media channels. All the data have in common that they were not originally created for the purpose of supporting scientific research. And the idea is to take the unstructured data and make structured data out of it to then analyze it as it has been done in the past with a traditional model of empirical research. So that is the BERD overview. And the next slide, please. Since no like a research data management system exists, we are in charge of setting up one. And we kicked off our like infrastructure thoughts. We were discussing how to set it up. Should we use a cloud infrastructure or a hosting model? A hosting model with a predefined amount of storage and a predefined of computing capacities. But since at that point in time, we did not know due to the new community we are developing, we did not know how much storage would we need. We did not know how much computing capacities would we need. And therefore, we have decided to go into a cloud infrastructure and not like buying in a hosting model or setting up like the servers in our own computing center. So then the next question was, what cloud should that be? And at that point in time, when we were like thinking about cloud infrastructures, when we were exploring cloud infrastructures, there was not much around. So there was a certain lack of cloud infrastructures within and for the science system in Germany. This, frankly, has changed since then. A most prominent example is Open Clouds for Research Environments, the OCRA environment, which is developed in an EU-funded project and which can be procured via Géant or DFN. So today we have a cloud solution for the science system, but at that point in time, that was too early to join the OCRA offer from Géant and DFN. And therefore, we decided to go with a commercial cloud infrastructure provider, which is IONOS. That's a German cloud infrastructure provider. That's the cloud provider which belongs to 1&1. And the reasons for that were, it's of course GDPR compliant. All the computer centers are based in Germany. For us, it was super important and good to can easily scale up storage and computing capacities. Of course, data security is and like safe data storage is no issue because they mirror all the data to a second cloud infrastructure within Germany. So these were the advantages. But of course, we are aware of maybe losing digital sovereignty because it's a commercial cloud provider, even if our own technology stack follows open science principles. And this will be addressed later on in Ahmed's presentation because we are using Invenio as an open source solution for a research data management framework. So that's indeed a science policy discussion. To what extent should a scientific research data management offer, which is open, be based on a commercial cloud infrastructure provider? The key point there, and today is not the right environment to address that, is to what extent do we get the data out of the cloud from a commercial provider? And at this point, I would like to hand over to Ahmed to enter into the details of the technical aspects of the cloud and the Invenio system. So Ahmed, it's your turn.
Thank you very much. Thanks, Klaus, for the great introduction on the project components about the cloud infrastructure. So as you mentioned, we had a huge amount of data, and the data is usually unstructured data. And we were thinking about how to handle this kind of data, let's say, first also to make a powerful search engine that allows researchers to search in different kind of repositories easily. And also how to host it, how to provide the entire environment, right? So I will try to tell you more about the different technical components of our project of BERD in our today's session. I would start with the part of the cloud infrastructure, how we are currently setting it up. And what you see here is a figure about from the cloud infrastructure from IONOS, right? And at the moment we have 4 main servers. 2 servers, one for testing, our code repositories and so on, and one for production. So when we wanted to make a release that is available for everyone, we put it there. Another server for mockups. So when we wanted to make a new feature and so on, we are discussing about it internally. So we have a separate mockup server. We also have an application server. And in this application server, we try to have a kind of a separate server for the search that is provided, for example, by Elasticsearch or OpenSearch, the open version of Elasticsearch. We have a messaging queue system with RabbitMQ. We have a storage that is handled by S3 object storage in IONOS. And all the servers at the moment are running with Ubuntu. We have also the web servers are using Nginx to handle requests and so on. Right? We had a basic load balancer component. So like every request that comes to us from externals and so on has to pass by this load balancer component and then goes to the servers afterwards. So that's our basic architecture, like for like the cloud infrastructure. And the development process that we are following in the project is not different than the development process that is followed everywhere else, right? So we start like by determining the requirements for our project. We defined like so many use cases coming from different partners, different universities, and so on. Out of those use cases, for example, we have a use case like about UCR and OCR and digitalizing books, and another use case about like a data marketplace and make them available and so on. So when we collected the use cases, we found that a lot of ideas are just scattered and let's say in texts, and we wanted to get them in one platform, right? We wanted to see how this is represented in a functional environment. And then we started by drawing, let's say, a simple wireframes, just to make sure that we are all aligned, like in the same idea. And then we tried to make like a more realistic views. This is the mockups. What I just mentioned is like the mockups are available in one separate server and so on. And then discuss about this mockups, and it's an agile iterative process. We always like discuss about how to enhance, let's say, the use case, enhance the mockups and so on, to reach like a general understanding of what BERD is, like, right? And then so BERD is that now we are still in the second year, so it's still a very, very early stage of the project, I would say, even though I think we reached a quite good understanding of what BERD is, right? And finally, is also to develop like the final platform or prototype. Here you find a very general overview of the project components, and starting from left to right, you find the business economics and related data. So there is a lot of repositories available, right? We wanted to have a repositories that will help companies, that will help researchers and so on to find content, right? There we start like with this kind of data, and we have a crawlers component like harvesters that is looking for different repositories, fetch them, and put them into our index, right? And everything you see in the right side, this is like inside Invenio. So Invenio offers is a really powerful research data management platform. It offers a reliable search engine with different features. And on top of Invenio, we are building more components, right? This is what I try to mention. Like we are building like an OCR component in Invenio. We are building the crawler component to fetch data into this Invenio instance, and so on and so on and so on. With the common data model, what we call common data model, it's usually like with different domains, they call it differently, right? So in computer science domain is called metadata schema, and in different domains is called common metadata model and so on. And that's basically try to get like a structure for unstructured data, right? So when you have like scientific papers, for example, when you have a database and so on, and you wanted to represent them in a schema, the schema should be like very representative. So for example, here, let's say we decided to use like a schema that is called DataSite. It's a well-known schema. And we are mapping different datasets to this schema, right? And we are trying to apply also fair principles to like those different kind of datasets. And a part of the challenges that we are facing is, for example, when you have a repository like Ecombase using a standard for language like English, for example, they represent English ENG, right? Another repository would represent English in EN, and another repository with English, and so on. And you wanted to map like this whole repository just to one standard. And that's exactly what the common data model is doing in this case, right? And so we have in BERD, we have a group that is working intensively on those topics. And with different universities and so on, we get together, we think about like our data sets, how to map them, and how to get them all in one place. The next component is the crawlers. And as I just mentioned, it's also like the challenge is like when you collect like those different data sources and put them in one place, like to map them all, we need to agree on one standard. This was like DataSite. That's what we agreed on. And we are currently still building like the crawlers component. So the crawlers itself in cases, so they have already like some kind of crawlers up and running. We try to connect it to our Invenio instance, right? And that's using like the REST API that Invenio is providing. And so the crawlers is collecting like the data sources, and then we map them into a one schema that is data side. And after the files are stored in our file system mapped, we then put it into Invenio instance, our Invenio instance, right? So that's what I would call from now on our BERD instance of the platform. So there is, so as I mentioned, the crawler component is provided by GASES. So that's the institute, and they already have GASES data search. Maybe some of you already have heard of GASES data search archive. It's a powerful search engine that contains a lot of data sources and so on. And a part of like those data sources, like a data sources, University of Manchester, Swedish National Data Archive, and so on and so on. There are a lot of data sources inside GASES data search. We are still in BERD try to find which kind of data sources we will have in our project. Still, we don't have a full list of let's say repositories that we want to harvest, but that should come also soon at one step. We are still thinking about like different other repositories like the IEEE data port, Harvard the Dataverse, and so on. So before I start with the demo, that's a quick words about Invenio. So Invenio is like having a flexible data model. That's like why we also, like when we surveyed different research data management platforms, we decided to have Invenio because of this. Like, let's say with the flexible data model, we have OpenSearch. That's like Elasticsearch as a powerful open search engine. And we have independent packages and a support of user communities as well. A user can make like a collection of dataset in a community and so on. It offers a lot of features, right? And so we don't let's say re-implement the wheel. We start from the state of the art somehow, and then we build on top of this more features. And that's what we choose as a starting point. And now I would start the demo of the current version of the platform. So everything you see here is still very, very early stage of the platform, right? So as I just mentioned, it's still the second year of the project. We still don't have a public version of the prototype that you currently see. And I don't think we will make it public soonish. We still need some time. We need to discuss also internally about different aspects and make it clear, like with the data policies, the legal aspects of publishing data. And we have a group about like also data stewardship. So let's say which kind of users should publish content, all right? And so on. So the platform, as you see in here, we have like a main search engine that searches over different resources. We have different portals as well. We are still defining the concepts of the portals, right? So like we have, for example, a machine learning portal. So the machine learning portal in the future will try to target the machine learning community. So like when you enter there, you should easily try to find, let's say, about specific topic. You find content about specific topic. So something like tasks, for example, like pre-processing tasks, sentiment analysis, deep learning models, and so on. You should also find some kind of paper with code, or let's say papers with datasets and so on, or you find datasets like for the machine learning community. And that's why we are now trying to shape up like how the portal, the machine learning portal will look like, to make it easier for the machine learning community to let's say find content that will be helpful for them. We have a data portal. That's what I would show you also in this demonstration. And the data portal is also to guide the users to how to upload data and how to search for data. And later on in the project, we will have a training and education portal. That's also because we probably will offer courses, right? And like those courses will be presented in a way. In BERD, we have, at the moment, we have BERD Academy, and we are offering like kind of different workshops and so on. And also we will publish, let's say, those workshops and advertisement in our platform in the future. And we have services portal, right? And so different services, as I mentioned, like the OCR service in the future, we will have different other services will be offered in this services portal, right? So it's still all a work in progress thing. And that's the community aspect that I mentioned, but I will not go into more details of the community aspects in this presentation. And I know that like those of you who knows Invenio already knows about the community aspects quite well. Yeah, so searching inside a content. So we have a search engine that contains different kind of contents, right? So like a marketplace dataset, an open dataset, and so on. I would take it like one step backward and open maybe the data portal and start from the step where we upload dataset, right? Or we upload like a content. And when you are not having a user, then you have to like create a user. That's like a completely normal process. Let's say, I don't know, we make just a user that is like, yeah, with my name, any type of email. And sign up. Okay, that was unexpected. Let's try it again. So. Okay, that worked now. It's probably because I used a username that is used already before. And yeah, that's why you can see it's a work in progress. Still had a lot of things that we need to improve, like with the error handling and so on. Yeah. So now I will create like a metadata record, and a metadata record, we are adding more data types to Invenio, right? So to address our own use cases, and I would just put an open data set. I would call it maybe economics dataset. And there are some fields that needs to be filled, right? I would just fill them quite quickly. So with the name of the author, for example, save. And we try to publish it. Okay, so now we have the economics dataset published. I open back like the search engine, and then and there we find it, right? And based on the data type that you choose when uploading your dataset, you will have a different view in here, right? So I chose already like dataset view. Later on, we will have an applicable machine learning approaches. It's still work in progress. So let's say if you uploaded a dataset and you wanted to have, let's say, a dataset about sentiment analysis and so on, you should in the future find related datasets to this dataset. You should find like articles that is related to this dataset. You should find also ML machine learning approaches that is actually helping your search for that is similar to your dataset. And in the future, we will have also like here different so we have filters, right? So inside the filters, you can filter for a specific data types. We have what is currently called book with data, but later on it will change, right? So one of the use cases is about digitizing books. And so the users will find, let's say, some kind of content, like one book that they are interested in digitizing, and they should vote it, like say, okay, upvote this book. I wanted it to be digitalized, right? And then it will go somehow to our backend, to the people who are responsible on the OCR service. They should then later on digitize it and make it available in BERD platform, right? So this entire use case I'm talking about is currently still not yet well defined, let's say, in our wireframes, in mockups, and so on. And so we try to define the use case much more than let's say we will implement it in one of the latest releases in our platform. One other use case also would be the knowledge graph use case, and like the enrichment of our metadata. And so that would be like more we apply like different machine learning models to enrich our data set with more data. Let's say when we wanted to tag when we want to tag like a one paper, right, with more keywords or something similar, and then we will apply those sentiment the semantic enrichment models to add like more metadata. Right. So I'm slowly coming to an end. So that's mainly like the filters that we are currently working on. We are reshaping everything that you see in here, right? So like most of the features are still coming from Invenio, from what you see in here, and we are still extending it. We are still in the process. Yeah. And at this point, yeah, that's an end for my presentation at this point. So thank you, everyone.
So thank you very much, Ahmed, Saleh, and Klaus Tochtermann for the presentation and the demo. And now I will stop the streaming on YouTube, and here in Zoom we can continue with questions.